So in this problem, you're given the following circuit where E is 12 volts, R is 10 ohms, C is 5 microfarads, and it starts off with having zero charge. L is equal to 2 millihenry. Now you're told that switch S has been at the position A for a very long time. What that is saying is that the current here has reached its maximum value of I max, where I max is equal to E divided by R. You're then told that at time is equal to 0, the switch is thrown to the position B, like so. So we're cutting off the battery and resistor, and we're just left with this LC circuit like this. So then you're asked to figure out what the charge is on the capacitor at time is equal to 1 second. Whenever you have an LC circuit, you know that U E max minus U B max is equal to 0. What this is saying is that there's going to be a certain amount of magnetic potential energy here and electric potential energy here. At any point, the difference between the two has to be equal to 0 because there's nowhere else for that energy to go. It's like the energy is either here or somewhere split between the two, but it cannot be exiting the system at all. So we're saying that U E max is equal to U B max. Okay, so then we know what these two values are. This is 1/2 Q squared max over C, and this is equal to 1/2 L I squared max. Now what is Q max? And the reason why we want to find Q max is because this is the equation we need to solve to figure out what the charge is on the capacitor. So then we get Q max is equal to I max square root of L times C. So then it makes sense why we have to figure out what I max was first, because we have to plug that in here as well. So then Q max is equal to E divided by R square root of L times C. So what we're going to do is then take this equation here and insert it into our equation for Q, which here it's a little q because it changes depending on the time. So then if I were to write that out, we have Q is equal to E over R square root of LC sine of omega t. Now the last thing we do before we substitute all our values in is figure out what omega is, where omega is just equal to 1 over square root of L times C. And then we can go ahead and say Q is equal to E over R square root of LC sine of T over square root of L times C. So now let's go ahead and plug everything into here. Q is equal to 12 volts divided by 10 ohms square root of 2 times 10 to the negative 3 Henry times 5 times 10 to the minus 6 farads sine of, and remember it's 1 second, divided by square root, and again 2 times 10 to the negative 3 Henrys, 5 times 10 to the negative 6 farads. So if you plug in everything, you should get something like Q is equal to negative 3.67 times 10 to the negative 5 coulombs. This negative sign is simply indicating that the polarity of our capacitor here is swapped relative to what we would expect it to be. So here it'd be plus, but it's actually going to be minus here and then plus here. And that is it for this question.